Hello and welcome back everyone to Universe Sandbox. Alright, so if we go ahead, we can just go ahead and shift this decimal place over by 1. And look at that! We put Mercury 10 times further away from the sun. How useful. Decimal places are so cool, aren't they? And we can actually go back around and do it again. We can move the decimal place upwards. Very nice. Now we're back to where we started. But we could also move it even further up, and now we are 10 times closer to the sun than we were before. We are going to use this concept to shrink the entire solar system by a factor of 10. See what happens. Maybe then we'll do it by a factor of 100, 1,000, million. This video will never end. Endless content for the rest of your life. You know you want it. You know you want to see me just keep adding decimals to these for years. So, let's go ahead and get started. Now, I'm just going to restart because it'll be more dramatic if we just go one at a time here. We'll start... Oh, shoot, I have to actually open the solar system one. Apologies, you know, can't just have empty space. I mean, you can, it's just not quite as exciting, you know? We need a high-quality sun. Alright, so obviously the sun's orbital period doesn't apply because, you know, everything's orbiting it, the sun isn't. Or okay, before you say the sun is orbiting the galaxy, that we're not simulating that, so sad. Alright, so we will start with Mercury and bring it 10 times closer to the sun. Go ahead and get the orbital period, boop, and look how much closer we get. And the temperature rapidly rising. Look at it go! Hopefully Mercury doesn't, like, evaporate into nothingness. There's a... Oh, wow. It is actually accelerating. It's... Oh, just because of the orbit isn't perfectly around the sun. We get a little bit of a, longer end here at the, periapsis? Yeah, because the apoapsis is the Wait, no, the apoapsis is the far one. So this is the apoapsis, that's the periapsis. You know, this isn't important. We'll just continue. I'm just thinking in Kerbal Space Program terms now, and that's unimportant. So let's go ahead and move Venus closer and see what happens. Now Venus, as everyone knows, has a very nice blanket on it. A very, very nice blanket, nice and warm, keeps all of that energy in, which means that its average temperature is already insanely high. So putting it this close to the sun may cause big issues. As we can see, the temperature is rising. Now, one interesting thing is that the blanket also reflects a bit of the sunlight, so it slows up, or it heats up more slowly, but as you can see, it heats up much more, it's more linear. It's just happening, and it doesn't show any sign of slowing down. Unlike Mercury, where we can already see it starting to plateau a little bit at 600 degrees. Which is warm, but, you know, not like end of the world warm. Well, I mean, for Earth, that would be end of the world warm, but Mercury isn't about to, like, dissolve into nothingness. So now let's go on to Earth. We already know what's going to happen. It's not going to be good. We're fragile beings, and getting this close to the sun is going to ruin our prospects. It's going to be awful. Immediately, Earth is going to go from 14 degrees, probably to like 30 within like 1 second, but we'll see what happens. I'm going to make it nice and slow for Earth because we actually can relate to this change. Well, we can't relate, quote unquote. Yes, maybe you can't relate to the Earth changing position, but you can relate to the temperature. So very, very quickly, we're going at like a minute per second now, and the average temperature of the Earth is moving more slowly than I expected. Let's go. Wow, it's actually taking hours for the change to be noticeable. That's impressive. But the global average temperature is rising pretty damn quickly. More quickly than Venus, as you can see. Venus went from 468 to 480, and Earth has already went from 14 to 18 in a much shorter amount of time. So, much shorter. I mean, now we're getting to the point of like total biological collapse. You know, we've raised the temperature by 6 degrees centigrade, Celsius, however you want to say it, and it's not 8 degrees. The green on the Earth is starting to fade away. It's kind of starting to look gray, very gray. I'm sure that's no problem. I'm sure everything's fine. I'm sure as time passes, nothing could possibly go wrong. All right, now we are at 35, 40 degrees Celsius. There's like no green left on Earth. Maybe a little bit in Maine, Canada, you know. The polar caps are not looking good. Antarctica has kind of given up on life. And as this continues, I mean, the nice thing is Florida won't be flooding anytime soon. Because we've actually gone past the glaciers melting and the sea level rising. Now we have to worry about the oceans evaporating away. That's how insane we're getting, with an average temperature of over 55 degrees Celsius. Yeah, that's pretty bad. For reference, that's not good. We're basically in an oven. We're halfway to boiling, so might as well speed things up a little bit. Oh, we did it! We hit boiling! The oceans are literally boiling away. Isn't that great? Yeah, I love it when the oceans just boil me. Now, there is a moment where all the lobster in the world will be perfectly cooked. So, for that moment, I'd like to say everything's alright. I want to just quickly look at the surface and see the temperature range. So actually, some parts of Earth are down to 48 still, but some parts, when it's in direct sunlight, hit 200 degrees Celsius. There would be massive, crazy storms from the amount of water vapor just in the air. Actually, I think we can actually look at the vapor chart. Yeah, here we go. All I have to do is water vapor pressure. Oh my god, look at the over here. That's a little bit intense. A little bit intense. All right, beautiful, very nice. Now continuing, we still have to get Mars. Mars may actually fare well from this because Mars is just freezing, so getting it, this is going to be way too close. But for a moment, Mars will be terraformed. For a very short moment. Ready? Let's watch Mars on its journey, becoming terraformed and then slowly dying again. But just for a moment, everything will be fine. Oh shoot. There we go. Alright, Mars, we're at negative 50, negative 40, negative 30. Oh, look at that. Very interesting. I wonder why the ice is moving. Maybe it's... I think the ice is actually melting in some areas and then being redistributed across the surface. That's the only real way I can explain the getting warmer, making it more icy. We're unlocking the water within. But soon it's going to be liquid water because we're at negative 10, 9, 8, 7, 6, 5, 4. Oh, look! The deepest grooves of Mars are starting to melt. And with the new fluid simulation, I'd expect that the water would pour into those craters. You will see. You will see what happens. Look at that. It's waking up. Wake me up inside. Mars. That's Mars theme song. Oh, the ice is fading away. Now it's at 30 degrees. Interesting. No real visible liquid water pooling up anywhere. Slightly disappointing. It's probably just because there's like no water. Not enough to make like oceans. Although I thought there was... Interesting. Very interesting. Just for the sake of fun, I'm gonna make a 1 kilometer sea to see if we can... Okay, we'll do 2, 3. I just want to see liquid water on Mars because it looks cool and it'll make me happy. Yeah, so like for this very temporary amount of time, Mars is kind of habitable because it got so much closer. Unfortunately, that's going to end as the temperature continues to rise. Mars does not have much protective layer when it comes to atmosphere. That means it also doesn't function as a blanket, but oh, the sad thing is it's actually, yeah, nah, it's not gonna happen. It's not gonna happen, it's too hot. We're all dead. Let's go look at Earth. Earth's at 300 degrees. For some reason, there's still water on the surface, though. I'm kind of concerned by this. I feel like something is horribly wrong. Do I need to turn off the There's got to be something I have to do to make this work. I feel like it's the climate system I have to turn off. Because it is 300 degrees on average. There should not be any water on Earth anymore. Just being honest at this point. Just being honest. I'm a little bit concerned. A little bit concerned. I don't know. Oh my god, you can modify specific grid cells. Okay, that's kind of cool. I didn't know that was a thing. Huh. Alright, well, yeah, tried our best. I like how the life likelihood is 64% still, even though it's hundreds of degrees. That's great. I feel like the game is just given up on Earth at this point. Alright, now we're just gonna grab... We're not gonna do these little guys. There's no real point. Jupiter! Get over here. Jupiter being 10 times... So shrinking them all by 10 times means that all the planets are much closer together now. Which, for NASA, would be really damn convenient. But getting Jupiter this close to the other planets may cause it to interfere a little bit more than usual. I mean, this is pretty damn close, especially to the Sun. It's probably going to cause the Sun to wobble around a bit more. We'll just also grab Saturn. Move Saturn over. The gas giants aren't going to be quite as exciting. Oh, that was rotational period. I wasn't... I wasn't supposed to change that. I was supposed to change this. 29.6 years. Makes me feel real young when Saturn hasn't even completed one round while I've been alive. 165 years! For Neptune. Holy guacamole, I never even knew it was that. That's intense. That is intense. What is... Oh, I forgot. Uranus. Don't make any jokes. Shut up. Okay, what is the, what? Oh, I missed. I missed Uranus. Oh, God. Shut up. Shut up, I know you're making the jokes. It's not necessary. Orbital period. 83 years! Damn! These planets really know how to sit around and do nothing. I'm almost, like, impressed. 251 years for Pluto. Nobody alive has experienced Pluto going around the sun. Wacky. Alright, we're all in place now. Jupiter and Saturn, I feel like, are gonna mess with each other. Like, the distance between them is small now. Like, it looks still pretty damn large, but going to, like, the... Realistically, the distance has been cut so far. Jupiter has so much mass, but still doesn't seem like the sun is really moving. It's getting pulled a little bit by Jupiter. Maybe we have to go a little bit closer. Maybe we have to do 100 times closer to get some interesting results. I mean, this is really damn close. Let's do it. You know what? We're getting to the end of the video. Let's go ahead and see what happens. Mercury, oh no! Mercury has reached the temperature at which it's just dissolving! No! It's being absolutely obliterated. Well, unfortunately, that's only going to get worse once we turn the orbital period to less than a day. Oh my god. Yeah. Goodbye. Goodbye, Mercury. Mercury just done. Venus! Hey, how... You're at 900 degrees now. Woo! Getting a little warm and toasty. Actually, I can see the particles from Mercury just flying off. And I think Venus is actually dropping some bits as well. Losing some mass. That's rough. That's rough, buddy. Alright. Let's go ahead and grab that orbital period and turn it to 2 days. Damn. Yeah, that temperature was really skyrocketing now. Earth, same thing. Earth is going to have, I can actually do the math pretty quickly. It's going to be like 3.6 something days. Yeah, 3.65 days. You know how you can figure that out? 365 days divided by 100. Genius. I don't know why I said 3.6 something, because I 100% should have known that that was a 5. But, you know, shut up. It's early. I just ran 5 miles. My brain isn't working properly. Okay? Thank you. Alright, Mars. Oh, looking so beautiful still. Even though it's 178 degrees, for some reason, still holding on to that water. I feel like they broke the water with this latest update that sets the sea level. It seems like the water is not being affected by the heat. Which is not good. Hopefully they fix that. Orbital period. We're gonna bring that down. 6.8 days. Jupiter. This is where it's going to get very interesting. Bringing Jupiter just this close. Oh, man. Look at how close that's going to be to Earth and them. Yeah, that's going to be mayhem. And getting Saturn that close to Jupiter as well. This is going to be intense. Boys and girls, are you ready for the most intense planet game stuff of your life? Not that there's been really much else that would compare in any way. Not much, but I'd like to say out of all of the planet games you've watched, this is going to be intense. Alright. No, not 0. Damn it, Pluto. This is why they don't consider you a planet, because you mess us up. Alright. Slow things down. Play. I'm just going to keep an eye on Jupiter at this point, because I feel like it's going to be the most interesting point. Of course, it stays on Neptune. Alright. Is Jupiter going to affect anything, being this close? Jupiter's gravitational pull is pretty massive compared to the other planets, and it is very, very close to the other planets. But I guess it's just not close enough. I mean, everything got closer to the sun, so the sun's gravitational pull will get a lot stronger too. Because, you know, gravity depends on distance. I'm really enjoying Mercury's heat graph here. It kind of looks like it's having a heart attack. I understand that my camera is kind of in front of the graphs now. I didn't think about that before. Apologies. Although this one, Venus is literally just a line. It's at 2,000 degrees now. Just not happy. Not digging the lifestyle. Mercury is, yeah, just being evaporated. Just turned into ash. Earth has actually reached its maximum temperature. Oh, the ocean's gone at long last. At long last, I don't even think it removed the ocean. I think the water is still under there. I can do a quick test. If it changes color when we change the surface, if we set the sea level. Oh no, it happened. It actually did it. Wow, very, very impressive. Will it go away again? Oh no, it's just stuck there now because we said it. That's hilarious. I like that. Alright, I expected slightly more insane things to happen. Slightly disappointed, so what I'm going to do is I'm going to set Jupiter even closer before the video ends so that we get some real excitement. There we go. Jupiter and Earth are best friends now. Best friends. Jupiter is moving more slowly than Earth because it's further away when it comes to the orbital period, so Earth is actually going to come up to Jupiter. So we'll see what happens during this approach. The Sun is much larger than Jupiter, but with Jupiter that much closer, Earth is going to get pulled towards Jupiter a little bit at least. Okay, it definitely did. Oh, yeah, no, it's got Earth. We're Jupiter has made the swoop, and wow, that was actually perfectly executed to eat Earth. That was really good. Good job. Jupiter. Very proud of you. That was a fantastic, fantastic move. You're not gonna miss, are you? I swear, if this is like a really lame miss. Are you kidding me? Oh. Okay, no, it hit. A grazing shot. Earth has been eaten. I expect that Jupiter is just going to go and eat everything now. There is no competition. Earth is gone, clap your hands. Earth is gone, clap your hands. So glad to know that Earth is gone. Really reduces my stress. Nothing really matters anymore. Your homework, who cares? Earth is gone. Yeah, it's causing all the other orbits to get wobbly, but it's not like crazy to the extent that it was. Oh, actually, Venus is getting kind of close. You can see it each time it goes around, it gets a little bit closer. Very interesting timing. Wow. Alright, maybe they're going to, no? I could just watch this for hours, but that doesn't make for good content. So you know what, I'm gonna say, that wasn't awful. We learned a bit, you know? I'm actually surprised at how well things held up. I thought things would have fallen apart a long time before that. A long time before that. So, thank you all for watching. Leave a like and subscribe if you enjoyed. And I will see you all next time. Supernova death. Woo! I love me some supernova death. Peace out. Hail Vooperia. Don't forget to subscribe.